Hello, I'm Breton, one of our MCAT tutors here at Inspira Advantage, where we help students get into med school and other professional programs. In this video series, we're going to talk about one of the most important topics within organic chemistry on the MCAT, carboxylic acids. Organic chemistry is overall a pretty low topic to study, but understanding carboxylic acids is incredibly high yield for both organic chemistry and biochemistry. In this video, we're going to look into the synthesis of carboxylic acids by oxidation and their breakdown by reduction. We first want to know how to synthesize carboxylic acids. The most basic way to do this is through oxidation. There are several potential starting points for the synthesis. We could use a primary alcohol or an aldehyde. Otherwise, we could use a primary or secondary alkyl group using a strong oxidizing agent like KMNO4, Na2Cr2O7, K2Cr2O7, or CrO3. Notice we've got a lot of chromium here, chromate. These are some of the most important reagents to know for organic chemistry because they are all oxidizing. These are very, very important. So what does this look like? Draw it out. Let's say we take this simple benzene with a nitrogen group and an extra methyl group. Now let's dose this with one of our oxidizing agents. How about KMNO4? Why not? We'll have to add a little bit of water and a little bit of heat, but our reaction in the end is going to be the exact same base structure. We're not going to bother with that nitro, but now instead of that CH3 group, instead of that methyl group, we're going to replace that with a carboxylic acid. This is the power of oxidizing agents. We can take something boring like a methyl group and turn it into something fun, interesting, and reactive, like a carboxylic acid. Once synthesized, we can react our carboxylic acid with various nucleophiles to make many different and useful products. Check out our part 2 video for a deep dive into this. But today, we're just going to finish this creation and destruction by showing you how we could then take this oxidized methyl to the carboxylic acid and turn that back into a methyl group, and the steps that it's going to proceed along the way. So we started off by talking about our oxidizing agents. I want to now introduce you to one of the most important reducing agents, lithium aluminum hydride. This will take a carboxylic acid and reduce it down to an alcohol. Let's look at how it does this. We're going to start with our carboxylic acid, just an R group, can be anything. We'll hit it with our lithium aluminum hydride. It needs to have some hydrogen. So this is then going to proceed through an intermediary step. So we're going to start with just having a nice aldehyde. We know that aldehydes are more oxidized than alcohols, so it would make sense that as we're reducing a carboxylic acid down, we'll pass through aldehyde land, which is exactly what we see here. Notice our OH group has just been turned into a hydrogen, here to here. Now this will proceed forward, have a bit of a rearrangement go on. This will proceed forward, more lithium aluminum hydride, till we have an unstable alk oxide ion. This is finally where, if treated with a little bit of acid, we can get a good old-fashioned alcohol. So this is how we can take a reducing agent, hit it with a carboxylic acid, bring us back down to an alcohol. Now that you have the foundational knowledge of how the MCAT will make and break carboxylic acids, we are going to build off of this in our next video, where we look at what molecules are then going to react with these carboxylic acids, and how you can predict this with high accuracy on the MCAT. Thank you so much for watching our first video on carboxylic acids, and I will see you next time as we continue the series.